Hello, in this lecture we will answer on two questions. The first question, we will find out the diameter of this orange circle, and in the second question we will find out the size of angle theta. So we'll start with the first question. In the drawing we have three semicircles, and inside the biggest semicircle we have two small semicircles and one orange circle, and we want to find out the diameter of this orange circle. We also know that the diameter of the smallest semicircle is 10 units. The diameter of this semicircle is equal to 10 units. Therefore the radius is equal to 5 units. The diameter of this semicircle is equal to 20 units. Therefore the radius is equal to 10 units. And the diameter of the biggest semicircle is equal to 10 plus 20, that is 30 units. Therefore its radius is equal to 15 units, and we want to find out the diameter of this orange circle. So we will define the radius of the orange circle, this circle, as R. I'll write it down. R is the radius of the orange circle according to our definition. And the center of this orange circle is defined as C, so I write it down. We define the center of the smallest semicircle, this semicircle, as X. We define the center of the biggest semicircle, that its radius is 15 units, as Y. This is the biggest semicircle. And we'll define the center of this semicircle as Z. In the next step, we'll join together the centers of the semicircles with the center of the orange circle, that is at point C. In order to find out the lengths of the line segments in this drawing, I will present to you two new rules. Actually, we have two types of tangency between two circles. Two circles can touch each other in two different ways. The first type of tangency between two circles is the external lunge. In the external lunge, the two circles are touching each other externally. Those two circles are touching each other externally at this point. This is the point of tendency between the two circles. We also note that the center of the small circle is at this point, point M, and the radius of this small circle is R, small r, while the center of the big circle is at point O, this point, and the radius of the big circle is equal to capital R. In this case, the distance between the centers of the two circles, that is to say the length of line segment MO, will be equal to the sum of the lengths of their radii. That is to say, it will be equal to capital R plus R. So whenever two circles are touching each other externally, then the distance between their centers will be equal to the sum of the length of their radii. And there is also another type of tendency between two circles. This is the internal lunge. In this case, the two circles are touching internally at this point. This is the point of tendency between the two circles, and the distance between their centers, that is to say the length of line segment MO, will be equal to the difference between the lengths of their radii. In this case, it will be equal to capital R minus small r. So we'll summarize the two new rules, and we'll say that whenever there is an external lunge between two circles, that is to say the two circles are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of the radii of the two circles. In this case, it will be equal to capital R plus small r, while if there is an internal lunge between two circles, like in this drawing, then the distance between the centers will be equal to the difference between the lengths of their radii. That is to say, it will be equal to capital R minus small r. We will use these two new rules in order to find out the lengths of the line segments in this drawing. So according to the two new rules that I mentioned, the length of line segment CX actually, what is the length of line segment CX? We know that C is the center of the orange circle with radius R. X is the center of the smallest semicircle with radius 5 units. And the two circles are touching each other externally at this point. This is the point of tendency between the two circles. And whenever you have two circles that are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to the radius of the orange circle, that is R, plus the radius of this semicircle, that is 5. In conclusion, we found out that Cx, that is to say the distance between their centers, it is equal to R plus 5. Okay, line segment with Cx equals to R plus 5. Likewise, we will find out the length of line segment CY. I repeat again that C is the center of the orange circle with radius R. Y is the center of the biggest semicircle with radius 15. The orange circle and the biggest semicircle have an internal notch between them at this point, that is to say they are touching each other internally at this point, and whenever you have two circles that are touching each other internally, then the distance between their centers will be equal to the sum of the lengths of their radii. Will be equal to the difference. It will be equal to the difference between the lengths of their radii. That is to say, it will be equal to the radius of the biggest semicircle, that is 15, minus the radius of the orange circle, that is r. In conclusion, we found out that line segment CY is equal to 15 minus r units in its length. Here, line segment CY equals to 15 minus y. Likewise, we will find out the value of line segment CZ. C is the center of the orange circle with radius r. Z is the center of this semicircle with radius 10. Those two circle and semicircle have an external notch between them at this point, that is to say they are touching each other externally at this point. And whenever two circles are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to the radius of the orange circle, that is r, plus the radius of this semicircle, that is 10. That is to say, line segment CZ will be equal to r plus 10. Okay, we found out that line segment CZ equals to r plus 10. Likewise, we will find out the length of line segment XY. X is the center of the smallest semicircle, this semicircle with radius 5. Y is the center of the biggest semicircle with radius 15. And the smallest semicircle and the biggest semicircle have an internal notch between them at this point, that is to say they are touching each other internally at this point, that is point A. Therefore, the distance between their centers will be equal to the difference between the lengths of their radii. That is to say, it will be equal to the radius of the biggest semicircle, that is 15, minus the radius of the smallest semicircle, this semicircle, that is 5. 15 minus 5 is 10, so we found out that xy equals to 10 units. Likewise, we'll find out the length of line segment xz. I repeat again that x is the center of the smallest semicircle with radius 5. Z is the center of this semicircle with radius 10. Those two semicircles have an external notch between them at this point, point P. Therefore, the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this semicircle, that is 5, plus the radius of this semicircle, that is 10. In conclusion, xz equals to 5 plus 10, that is 15. Okay, we found out that line segment xz equals to 15 units. So we actually found out that all the lengths of the line segments in this drawing. In the next step, I will present to you a new law, that is the law of cosines. The law of cosine is true in any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. We know that side AB of triangle ABC equals to A units in its length. Side BC equals to B units in its length. The angle between side AB and side BC is theta. And we also know that side AC of triangle ABC equals to C units in its length. Then, according to the law of cosines, we get that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Okay, and the Pythagoras theorem is a special case of the law of cosines when angle theta is equal to 90 degrees. When this angle theta is equal to 90 degrees, then triangle ABC will be a right triangle, and in this equation we get that cosine 90 degrees equals to 0. 0 times anything is 0. So what is left from this formula is that C squared equals to A squared plus B squared, and this is exactly the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In conclusion, the Pythagoras theorem is a special case of the law of cosines when angle theta is equal to 90 degrees, and then triangle ABC will be a right triangle. Okay, so we will implement the law of cosines in triangle CXY. So I'll copy triangle CXY in a new page, and we'll implement the law of cosines in triangle CXY. Okay, so this is triangle CXY that I copied from the original drawing. This is angle theta. We have already found out that side CX, the length of CX is R plus 5 units. xy equals to 10 units, according to what we have already found out. And cy equals to 15 minus y units. So, according to the law of cosines, this will be equation number 1. We will get that cy squared will be equal to cx squared plus xy squared minus 2 times cx times xy times cosine theta. In the next step, we will substitute cy by 15 minus y. We will substitute cx by r plus 5. It is actually not 15 minus y, but 15 minus r, of course. So I will fix it. This is 15 minus r. And also cy is equal to 15 minus r. I'll repeat again. Here, 9 segment cy Here, C is the center of the orange circle with radius r. Y is the center of the biggest semicircle with radius 15. And those two circle and semicircle have an internal notch between them at this point, that is to say they are touching each other internally at this point. Therefore, the distance between their centers will be equal to the difference between the lengths of their radii. That is to say, it will be equal to the radius of the biggest semicircle, that is 15, minus the radius of the orange circle, that is r. That is to say, cy equals to 15 minus r. Okay, cy equals to 15 minus r. Now we will substitute cy by 15 minus r. We will substitute xy by 10, and we will substitute xc by r plus 5. So we'll do it now, and we'll get that according to equation number 1, cy squared equals to 15 minus r squared. That is equal to cx squared. Cx is r plus 5, therefore cx squared is r plus 5 squared plus xy squared. Xy is 10, so xy squared is 10 squared, that is 100, minus 2 times r plus 5, cx is r plus 5, times xy, that is 10, times cosine theta. We will open the brackets on both sides of equation number 1, and we'll get that according to equation number 1, 15 minus r square equals to 15 square, that is 225, plus r square, minus 2 times 15 times r is minus 30 times r, and it is equal to r plus 5 square. R plus 5 square equals to r square plus 5 square, that is 25, plus 2 times r times 5 is plus 10r, plus 100, minus 2 times 10 is minus 20, times r plus 5 times cosine theta, here we have r square on both sides of equation number 1, so r square will get cancelled. What is left from equation number 1 after we cancelled r square? What is left? It is actually here. In this side of equation number 1, we have 225 minus 30r, and on the other side of equation number 1, we have here 25 plus 100 is 125, plus 10r, minus 20 times r plus 5 times cosine theta. We will subtract 125 from this equation, equation number 1. 225 minus 125 is 100. We will subtract 10r from this equation, equation number 1, and we will get that minus 30r minus 10r is minus 40r, and it is equal to minus 20 times r plus 5 times cosine theta. We will multiply equation number 1 by minus 1, and we will get that 100 times minus 1 is minus 100, minus 40r times minus r is plus 40r, minus 20 times minus 1 is plus 20, so here we have 20 times r plus 5 times cosine theta. Here we will divide equation number 1 by 20 times r plus 5, and we will get that cosine theta equals to 40r minus 100 over 20 times r plus 5. Here we will divide both the numerator and the denominator of this set of equation number 1 by 20, and we will get that 40r over 20 is 2r, minus 100 over 20 is minus 5, 20 over 20 is 1, so in the denominator what is left is only r plus 5, So we actually found out that according to equation number 1, cosine theta equals to 2r minus 5 over r plus 5. Okay? In the next step, we will implement the law of cosines on triangle CXZ, so I will copy triangle CXZ in a new page, and we will implement the law of cosines in this triangle, triangle CXZ. We have already found out that xz is equal to xz equals to 15 units, xc is equal to r plus 5 units, and cz equals to r plus 10 units. And this is of course angle theta. So we'll implement the law of cosines in this triangle, triangle CXZ. This will be equation number 2. According to equation number 2, we will get that CZ squared equals to CX squared plus XZ squared minus 2 times CX times XZ times cosine theta. Here we will open the brackets on both sides of equation number 2, and we will get that actually, first of all, we will substitute CZ by r plus 10, we will substitute XZ by 15, and we will substitute XC by r plus 5, and we will get that CZ is r plus 10, therefore CZ squared will be equal to r plus 10 squared. And it is equal to CX squared. CX equals to r plus 5, so CX squared will be equal to r plus 5 squared plus XZ squared. XZ equals to 15 units, therefore XZ squared will be equal to 15 squared, that is 225, minus 2 times r plus 5 times XZ, that is 15, times cosine theta. Here we will open the brackets on both sides of equation number 2, and we will get that according to equation number 2, r plus 10 squared is equal to r squared plus 10 squared, that is 100, plus 2 times r times 10 is plus 20r, and it is equal to r plus 5 squared is r squared, plus 5 squared is 25. Plus 2 times r times 5 is plus 10r, plus 225, minus 2 times 15 is minus 30 times r plus 5 times cosine theta, here we have r squared on both sides of equation number 2, so r squared will get cancelled. So in this side of equation number 2 we have 100 plus 20r, and on the other side of equation number 2 we have 25 plus 225 is 250. Plus 10r minus 30 times r plus 5 times cosine theta. Okay? So here we will subtract 250 from equation number 2, and we will get that 100 minus 250 is equal to minus 150. We will subtract 10r from this equation, equation number 2, and we will get that 20r minus 10r is 10r. And it is equal to minus 30 times 5 plus r times cosine theta. Okay? Here we will multiply equation number 2 by minus 1, and we will get that according to equation number 2, minus 150 times minus 1 is 150, plus 150, 10r plus minus 1 is minus 10r, and it is equal to minus 30 times minus 1 is plus 30, so it will be 30 times r plus 5 times cosine theta. Here we will divide the equation number 2 by 30 times r plus 5, and we will get that according to equation number 2, cosine theta is equal to 150 minus 10r over 30 times r plus 5. We will divide this side of equation number 2, both the numerator and the denominator, by 10, and we will get that 150 over 10 is 15. And minus 10r over 10 is minus r. 30 over 10 is 3, so in the denominator we will have 3 times r plus 5. So we actually found out that according to equation number 2, cosine theta is equal to 15 minus r over 3 times r plus 5 but we have already found out that according to equation number 1, cosine theta is equal to 2r minus 5 over r plus 5. We have two different expressions for cosine theta. In the next step, we will create equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So according to equation number 3, we will get that cosine theta according to equation number 1, that is actually 2r minus 5 over r plus 5, must be equal to cosine theta according to equation number 2, that is actually 15 minus r over 3 times r plus 5. Here we will multiply equation number 3 by r plus 5. So r plus 5 will get cancelled in the denominator. In the next step, we will multiply equation number 3 by 3, and we will get that according to equation number 3, 3 times 2r minus 5 equals to 15 minus r. We will open the brackets on both sides of equation number 3, and we will get that according to equation number 3, 3 times 2r is 6r, and 3 times minus 5 is minus 15, and it is equal to 15 minus r. We will add to equation number 3 r, and we will also add 15, and we'll get according to equation number 3, 6r plus r is 7r, and 15 plus 15 is 30. So according to equation number 3, we got that 7r equals to 30. We'll divide equation number 3 by 7, and we get that according to equation number 3, r, the radius of the orange the radius of the orange circle, is equal to 30 over 7 units. And we know that the diameter of any circle or semicircle is twice as large as the radius. Therefore, we will get that the diameter of the orange circle is equal to 2 times the radius of the orange circle, that is actually 2 times r, and r equals to 30 over 7, so it is 2 times 30 over 7. That is actually equals to 60 over 7 units. So the diameter of the orange circle is equal to either 60 over 7 units, or in terms of numbers, it equals to 7.8 8.5714 units. I'll repeat again. Diameter of the orange circle, the diameter of this orange circle is equal to either 60/7 units, or in terms of numbers, it equals to 8.5714 units. In the next step, I will summarize the lecture. Actually, we wanted to find out the diameter of this orange circle. In the drawing, we have three semicircles. The radius of the biggest semicircle is equal to 15 units. The radius of the smallest semicircle is equal to 5 units, and the radius of this semicircle is equal to 10 units. And we want to find out the diameter of this orange circle. So we defined the center of the orange circle as C, and the radius of the orange circle is defined as R. We defined the center of the smallest semicircle as X. We defined the biggest semicircle, the center of the biggest semicircle as Y, and we defined the center of this semicircle as Z. Then we join together the centers of the semicircles with the center of the orange circle that is at point C, and I presented to you two new rules that is related to two circles that are tangent to each other at one point. We have two types of tangency between two circles. The first type of tangency is the external lunge, when the two circles are touching each other externally. Then the distance, those two circles are touching each other externally at this point. This is the point of tangency. Then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to small r plus capital R. This is so the external lunge is the first type of tendency between two circles, and we also have a second type of tendency between two circles when the two circles are touching each other internally. Then the distance between their centers, that is to say MO, will be equal to the difference between the lengths of their radii. That is to say, it will be equal to capital R minus small r. So we implemented the two new rules in our drawing. So here CX, the length of line segment CX will be equal to, here we have C is the center of the orange circle, that its radius is R according to our definition. X is the center of the semicircle with radius 5. Those two circles and semicircles have an external length between them at this point. That is to say, they are touching each other externally at this point. Therefore, the distance between their centers will be equal to the sum of the lengths of the radii. That is to say, it will be equal to the radius of the semicircle that is r plus the radius of the smallest semicircle that is 5. That is to say, cx equals to 5 units. That is to say, cx equals to r plus 5 units. Cx equals to r plus 5 units. Then we calculated the value of line segment cy. C is the center of the orange semicircle, y is the center of the biggest semicircle with radius 15. The biggest semicircle and the orange circle have an internal knot between them at this point, and whenever we have two circles with an internal knot between them, then the distance between their centers will be equal to the difference between the lengths of their radii. That is to say, it will be equal to the radius of the biggest semicircle, that is 15, minus the radius of the orange circle, that is r. In conclusion, we found out that cy equals to 15 minus r. Again, cy is equal to 15 minus r. Likewise, write it again. cy is equal to 15 minus r. Likewise, we calculated the value of line segment CZ. C is the center of the orange circle with radius r. Z is the center of this semicircle with radius 10. Those two circle and semicircle have an external knot between them at this point. That is to say, they are touching each other externally at this point. Therefore, the distance between their centers, CZ, will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this orange circle, that is r, plus the radius of this semicircle, that is 10. So in conclusion, we found out that line segment CZ equals to r plus 10. Likewise, we calculated the value of line segment XY. X is the radius of the smallest semicircle. X is the center of the smallest semicircle with radius 5. Y is the radius of the biggest semicircle. Y is the center of the biggest semicircle with radius 15. Those two semicircles have an internal knot between them at this point. That is to say, they are touching each other internally at this point, point A. Therefore, the distance between their centers will be equal to the difference between the lengths of their radii. That is to say, it will be equal to the radius of the biggest circle, that is 15, minus the radius of the smallest semicircle, that is 5. So in conclusion, we found out that xy equals to 15 minus 5, that is 10 units. Likewise, we calculated the length of line segment xz. X is the center of the smallest semicircle with radius 5. Z is the center of this semicircle with radius 10. Those two semicircles have an external knot between them at this point, point P. Therefore, the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this semicircle, that is 5, plus the radius of this semicircle, that is 10. That is to say, it will be equal to 5 plus 10, that is 15. So we found out that xz equals to 15 units. Then I presented to you the law of cosines that is true in any triangle. Here we have triangle ABC that could be any triangle. AB equals to A units in its length, BC equals to B units in its length, and AC equals to C units in its length. Then, the angle between side AB and side BC is theta. Then, according to the law of cosines, C squared will be equal to A squared plus B squared minus 2 times AB times cosine theta. And the Pythagoras theorem is a special case of the law of cosines when theta is equal to 90 degrees. When angle theta is equal to 90 degrees, then triangle ABC is a right triangle. And we have here the Pythagoras theorem. If theta equals to 90 degrees, then cosine 90 degrees equals to 0. So 0 times anything is 0. So minus 2 times AB times cosine theta will be equal to 0. And we get the Pythagoras theorem that C squared equals to A squared plus B squared. That is to say, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In conclusion, the Pythagoras theorem is a special case of the law of cosines when theta equals to 90 degrees, and then we are talking on a right triangle. So we implemented the law of cosines in our triangle CXY, this triangle, so I copied this triangle in a new page and we implemented the law of cosines in this triangle CXY. CX, we have already found out that CX equals to R plus 5, XY equals to 10 units, CY equals to 15 minus R. So according to the Pythagoras theorem, we get that CY squared equals to CX squared plus XY squared minus 2 times CX times XY times cosine theta. Okay? CY is 15 minus R, so CY squared is 15 minus R squared. That is equal to CX squared. CX is R plus 5, so CX squared is R plus 5 squared. Plus XY. XY is equal to 10 units, so XY squared is 10 squared, that is 100. Minus 2 times CX is R plus 5, XY is 10. So it is minus 2 times R plus 5 plus 10 times cosine theta. We open the brackets on both sides of equation number 1. And we got that 15 minus R squared equals to 15 squared, that is 225, plus R squared minus 2 times 15 times R is minus 30R. And it is equal to R plus 5 squared. R plus 5 squared equals to R squared plus 5 squared, that is 25, plus 2 times R plus 5 is 10R, and plus 100 minus 2 times 20 is minus 20 times R plus 5 times cosine theta. Here we have R squared on both sides of equation number 1, so R squared will get cancelled, and we have here 225 minus 30R equals to 25 plus 100 is 125 plus 10R minus 20 times r plus 5 times cosine theta. So here we subtracted 125 from this equation, equation number 1, and we got that 225 minus 125 is 100, and here we subtracted also 10r from this equation, equation number 1, and we got that minus 30r minus 10r is minus 40r. So in this side of the equation we have 100 minus 40r, that is equal to minus 20 times r plus 5 times cosine theta. Then we multiply the equation number 1 by minus 1, and we get that 100 times minus 1 times minus 1 is minus 100, minus 40r times minus 1 is equal to plus 40r. So in conclusion, we got that 40r minus 100 equals to minus 20 times minus 1 is plus 20. So in conclusion, we got that 40r minus 100 equals to 20 times r plus 5 times cosine theta. Then we divided equation number 1 by 20 times r plus 5, and we got that cosine theta equals to 40r minus 100 over 20 times r plus 5. Here we divided both the numerator and the denominator on this side of equation number 1 by 20, and we got that 40r over 20 is 2r, minus 100 over 20 is minus 5, 20 over 20 is 1. So in conclusion, we found out that according to equation number 1, cosine theta equals to 2r minus 5 over r plus 5. Then I copied triangle CXZ in this new page from the original drawing, and we implemented the law of cosines in this triangle, triangle CXZ. We have already found out that CZ equals to r plus 10, XZ equals to 15, and CX equals to r plus 5. Okay, so according to the law of cosines, we will get that CZ square equals to CX square plus XZ square minus 2 times CX times XZ times cosine theta. Okay, then we substituted CZ by r plus 10, we substituted XZ by 15, and we substituted XC by r plus 5. And we got that according to equation number 2, CZ square equals to r plus 10 square, CX is r plus 5, so CX square is r plus 5 square, and it is equal to XZ it is equal to XZ square. XZ is 15, so XZ square is 15 square. 15 square is 225, minus 2 times CX is r plus 5, and XZ is 15 times cosine theta. Here we have r square on both sides of the equation, so r square will get cancelled. Actually, we open the brackets here, and we got that r plus 10 square equals to r square plus 10 square, that is 100, plus 2 times r times 10 is plus 20r, and it is equal to r plus 5 square. R plus 5 square equals to r square plus 5 square, that is 25, plus 2 times r times 5 is plus 10r, and plus 225 minus 2 times 15 is minus 2 times 15 is minus 30 times r plus 5 times cosine theta. So here we have r square on both sides of the equation, so r square will get cancelled, and what is left from equation number 2 after we cancel r square, what is left, it is actually 100 plus 20r on this side of equation number 2, and on the other side of equation number 2 we have 25 plus 225 is 250, plus 10r minus 30 times r plus 5 times cosine theta. Then we subtracted 250 from this equation, equation number 2, and we got that 100 minus 250 is minus 150. and we subtracted 10r from this equation, equation number 2, and we got that 20r minus 10r is 10r. And it is equal to minus 30 times r plus 5 times cosine theta. Then we multiplied equation number 2 by minus 1, and we got that minus 150 times minus 1 is 150, and 10r minus 1 times minus 1 is minus 10r. Minus 30 times minus 1 is plus 30, so in conclusion we got that 150 minus 10r equals to 50 times r plus 5 times cosine theta. We divided equation number 2 by 30 times r plus 5, and we got that according to equation number 2, cosine theta equals to 150 minus 10r over 30 times r plus 5. Then we divided both the numerator and the denominator of this side of equation number 2 by 10, and we got that 150 minus 10 is 15, minus 10r over 10 is minus r, and 30 over 10 is 3. So in conclusion, we found out that according to equation number 2, cosine theta equals to 15 minus r over 3 times r plus 5. And according to equation number 1, we have already found out that cosine theta equals to 2r minus 5 over r plus 5. Okay? Then we created equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So cosine theta according to equation number 1 is 2r minus 5 over r plus 5. And it must be equal to cosine theta according to equation number 2, that is actually 15 minus r over 3 times r plus 5. Then we multiply the equation number 3 by r plus 5, so r plus 5 will get cancelled from the denominator. Then we multiply the equation number 3 by 3, and we found out that 3 times 2r minus 5 equals to 15 minus r. We open the brackets on this side of equation number 3, and we got that 3 times 2r minus 5 is 3 times 2r is 6r, and 3 times minus 5 equals to minus 15, and it is equal to 15 minus r. We added r to equation number 3, and we added also 15 to equation number 3, and we got that 6r plus r is 7r, and 15 plus 15 is 30. So in conclusion, we found out that according to equation number 3, 7r equals to 30. Then we divided equation number 3 by 7, and we got that r, the radius of the orange circle, equals to 30 over 7 units. But we want to find out the diameter of the semicircle, the diameter of the orange circle, and the diameter is twice as large as the radius. Therefore, the diameter of the orange circle will be equal 2 times the radius of the orange circle, that is 2 times, and the radius of the orange circle is equal to 30 over 7. So 2 times 30 over 7 is 60 over 7 units. So in conclusion, we found out that the diameter of this orange circle equals to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. Okay, we finished the first question. In the next step, we'll solve the second question. In the drawing, we have a quarter circle. Inside this quarter circle, we have square ABCO, and inside this quarter circle, we have also this angle, that is angle A and B. Angle A and B is a right angle, it is equal to 90 degrees. And we also have angle BQC, according to what is given as the question, angle BQC equals to theta, and we want to find out the value of this angle theta. So first of all, because of the fact that this is a quarter circle, then the length of OQ must be equal to the radius of the quarter circle. So we'll define the radius of the quarter circle as capital R. Therefore, the value of line segment OQ will be equal to the radius of the quarter circle, that is actually equals to capital R. Okay, it is equal to capital R. The radius of the quarter circle equals to capital R because it is equal to OQ. In the next step, in order to find out the value of the size of angle theta, we will make a construction. We will extend line segment MA, and we will also extend line segment QO until they intersect with each other. And we will define the intersection point between extended MA line segment and the extended QO line segment is point N. In the next step, we will complete the quarter circle to a semicircle. So we have here a semicircle. We made it from a quarter circle, a semicircle. And here inside this semicircle, we have a peripheral angle NMQ that is equal to 90 degrees. Okay? I repeat again. Inside this semicircle that we created from the quarter circle, we have peripheral angle NMQ that is equal to 90 degrees. And we also have wall number 1 that is related to a peripheral angle that is equal to 90 degrees. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. repeat the rule number 1. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. So in our drawing, we have the peripheral angle NMQ that is equal to 90 degrees, and according to rule number 1, the peripheral angle NMQ that is equal to 90 degrees must rest on the diameter. And we know that the peripheral angle NMQ rests on MQ. Therefore, MQ must be the diameter of the semicircle. So according to rule number 1, we will conclude that MQ is the diameter of the semicircle. According to rule number 1, NQ is the diameter of the semicircle because of the fact that it is equal to 90 degrees. So we know that OQ is the radius of the semicircle that is equal to capital R, and we know that NQ that is the diameter is twice as large as the radius, that is to say NQ equals to 2R. And we already found out that QO is equal to R. Therefore, what is the value of line segment NO? From the drawing you can see that the value of line segment NO is equal to NQ minus QO. I'll repeat again. The value of line segment NO is equal to NQ minus QO. So NO is equal to NQ, that is 2R, minus QO, that is R. 2R minus R is R, so we found out that the value of line segment NO is R, that is to say it is the radius of the semicircle, and Q equals to R. In the next step, we will focus on the right triangle NMQ. In the right triangle NMQ, this right angle, we know that the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle NMQ? We have this angle that is the right angle, it is equal to 90 degrees. We have also this angle that is equal to theta according to what is given us the question. And we have also angle MNQ that is the missing angle. So we know that in total the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So we will subtract 90 degrees from this equation, and we will get that angle theta plus angle MNQ equals to 180 degrees minus 90 degrees, it is 90 degrees. Here we will subtract angle theta from this equation, and we will get that the value of angle MNO is equal to 90 degrees minus theta. Okay, angle MNO equals to 90 degrees minus theta. We can write here that the size of angle MNQ is equal to 90 degrees minus theta. And we also know that all the angles inside the square are right angles. So we know that all the angles inside square A, B, C, O are right angles. So we draw here 4 right angles. It is true in any square. And because of the fact that NQ is the diameter of this semicircle, NQ must be a straight line because it is a diameter. So I'm going to write that down, that NQ is a straight line. I'll repeat again, because of the fact that NQ is the diameter, it must be a straight line. Therefore, we can write down that NQ is a straight line. Line segment NQ is diameter. It must be a straight line, so NQ is a straight line. And we also have rule number 2. That states that the sum of the angles on one side of a straight line is equal to 180 degrees. I repeat again on rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if you focus on the upper side of the straight line NQ at point O, then according to rule number 2, on the upper side of NQ at point O, the sum of the angles must be equal to 180 degrees. So which angles we have at point O on the upper side of NQ? We have here 90 degrees, and we have also angle here, angle AON. In total, the sum of those two angles must be equal to 180 degrees. I'll repeat again. On the upper side of the straight line NQ at point O, the sum of the angles must be equal to 180 degrees. So which angles we have at point O? On the upper side of NQ we have 90 degrees, and we also have angle AON. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. So we subtract 90 degrees from this equation and we get that angle AON is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that angle AON is equal to 90 degrees. Here angle AO. Actually, here we subtract. Okay, so I found out that angle AON is equal to 90 degrees. So this angle AON equals to 90 degrees. Likewise, if you focus on the upper side of the straight line NQ at point C, then the sum of the angles must be equal to 180 degrees. So which angles we have on the upper side of the straight line NQ at point C? We have here 90 degrees. And we have also here angle BCQ. So in total, the sum of those two angles must be equal to 180 degrees according to rule number 2. Here we subtract 90 degrees from this equation and we get that the value of angle BCQ is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that angle BCQ is a right angle, it is equal to 90 degrees. We focus on the right triangle, triangle BCQ. In the right triangle, triangle BCQ, we know that the sum of the angles must be equal to 180 degrees. So which angles we have inside triangle BCQ? We have here 90 degrees. We have also angle theta. And we have also this angle that is actually angle CBQ. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we will subtract 90 degrees from this equation, and we get that theta plus angle CBQ in total must be equal to 180 degrees minus 90 degrees, it is 90 degrees. Here we subtract theta from this equation and we get that angle CBQ, the missing angle, equals to 90 degrees minus theta. So we can write down here that angle CBQ, the missing angle, is equal to 90 degrees minus theta. So we actually found out that all the angles, actually in the next step, we will focus on the right triangle, triangle A and O. In the right triangle, triangle A and O, this right triangle, we know that the sum of the angles must be equal to 180 degrees. So which angles we have inside the right triangle, triangle A and O? We have right angle that is equal to 90 degrees plus this angle that is equal to 90 degrees minus theta plus this angle that is equal to angle NAO. In total, the sum of those three angles must be equal to 180 degrees. I'll repeat again, the sum of the angles in the right triangle, triangle A and O must be equal to 180 degrees. So 90 degrees plus 90 degrees, that is actually 90 degrees minus theta plus the third angle that is angle NAO. In total, the sum of those three angles must be equal to 180 degrees. 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on both sides of the equation of this equation. So 180 degrees will get cancelled, and we left only with minus theta plus angle NAO that is equal to 0. We will add angle theta to this equation, and we will get that angle NAO is equal to theta. So I found out that angle NAO is equal to theta. This angle equals to theta. So we actually found out that all the angles of triangle A and O can go into all the angles of triangle BCQ. Why? Because both those two triangles have angle that is equal to theta. Both those two triangles have angle that is equal to 90 degrees minus theta. And both those two triangles have a right angle that is equal to 90 degrees. Therefore, all the angles of the right triangle, triangle BCQ can go into all the angles of the right triangle, triangle A and O. Therefore, we can conclude that the right triangle, triangle A and O, is similar. This is the sign of similar to the right triangle, triangle BCQ, according to angle similarity rule. Okay, and from the fact that those two triangles are similar to each other, we conclude that the following relationship exists between their sides. We conclude that CQ over OA is equal to BC over NO. I'll repeat again. From the fact that triangle NO is similar to triangle BCO, we conclude that CO over OA equals to BC over NO. It's actually CQ. CQ, that CQ over OA equals to BC over NO. We'll find out the length of CQ. CQ, it is actually equals to QO minus OC. I'll repeat again. CQ equals to QO minus OC, so CQ is equal to QO, that is R, minus OC. We define OC as A, so CQ will be equal to R minus A. So OC equals to A according to our definition, and we know that all the sides of a square are equal to each other, so all the sides of square ABCO will be equal to A according to our definition. So we found out that CQ equals to R over A, so we can substitute CQ in equation number 1 by R over A. We'll do it now and we'll get that CQ that is equal to R minus A over OA. OA is also equals to A, so we substitute OA in equation number 1 by A, and it is equal to BC. BC is also equals to A, so we substitute BC by A in equation number 1 over NO. NO is equal to R. So in conclusion, we found out that according to equation number 1, R minus A over A equals to A over R. We'll split this expression to two parts. R minus A over A equals to R over A minus A over A, that is minus 1, and it is equal to A over R. Okay, in the next step, we will focus on the right triangle, triangle AON. In the right triangle, triangle AON, we know that tangent theta is equal to R over A I'll repeat again. In the right triangle, triangle AON, tangent theta equals to R over A. Now we can substitute R over A in this equation, equation number 1, by tangent theta. We do it now and we get that according to equation number 1, R over A is equal to tangent theta minus 1. It is equal to A over R, but A over R is 1 over R over A. Now we can substitute R over A by tangent theta. We'll do it now, and we get that according to equation number 1, tangent theta minus 1 equals to 1 over R over A is tangent theta. So we substitute R over A in this equation, equation number 1, by tangent theta. We will multiply this equation by tangent theta. and we get that tangent theta times tangent theta is tangent square theta. Minus 1 times tangent theta is minus tangent theta, and it is equal to 1. We subtract 1 from this equation, equation number 1, and we get that tangent square theta minus tangent theta minus 1 equals to 0. So we have here a quadratic equation. The variable that we are looking for in this quadratic equation is tangent theta, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of a quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula. Actually, x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, the coefficient a is equal to 1, the coefficient b is equals to minus 1, and the coefficient c is also equals to minus 1. So, and x, the variable that we are looking for, is actually equals to tangent theta. So we put the data inside the equation from x, and if we will find out the value or the values of tangent theta, because x equals to tangent theta. So we get that tangent theta is equal to minus b. B is equal to minus 1, so minus b is minus 1, that is 1, plus minus square root of b squared. B is equal to minus 1, so b squared is minus 1 squared is 1, plus minus 4 times a is 1, times c is minus 1, over 2a. A is 1, so 2 times 1 is 2. So we got that according to this equation, we get that tangent theta equals to 1 plus minus we have here minus 4 times minus 1 is 4, and 4 plus 1 is 5. So inside the root we have 5 over 2. So here we will have two solutions that are possible for tangent theta. The first solution is the tangent theta is equal to 1 plus square root of 5 over 2. And the second solution for tangent theta is the tangent theta equals to 1 minus square root of 5 over 2. That is actually a negative solution. 1 minus square root of 5 over 2 is less than 0, it is a negative. If we focus on our drawing, we have here the right triangle, triangle NMQ. In this right triangle, triangle NMQ, we have angle 90 degrees minus theta. So this angle, it is absolutely a positive angle because it is one out of 3 angles of a right triangle. Therefore, the angle that is 90 degrees minus theta, it is a positive angle. So we can write down that 90 degrees minus theta, it is a positive number, that is to say it is greater than 0. We will add theta to this inequality, and we get that 90 degrees is greater than theta. That is for one side, but in this right triangle, triangle NMQ, we have also angle theta. Angle theta is 1 out of 3 angles of a right triangle. Therefore, it is absolutely a positive angle. That is to say, theta is greater than 0. So we found out that angle theta, from one side it is less than 90 degrees, and from the other side it is greater than 0. So in those range of angles, from 0 to 90 degrees, the function tangents itself, tangents theta will be positive number. Tangents theta is greater than 0. But according to the second solution, according to this solution, tangents theta is negative. And here we found out that tangents theta must be a positive number. So we have here a contradiction. Therefore, this solution is the incorrect solution. We will cancel this solution. And we left only with the solution that tangents theta is equal to 1 plus square root of 5 over 2. We want to find out the value of theta itself. So we will operate the inverse function, the opposite function of tangents on the result, that is 1 plus square root of 5 over 2, and we'll find out that the value of tangents itself is equal to 58.28 degrees. I will check it here. So we have square root of 5 plus 1 over 2, and the inverse function of tangents is 58.28 degrees. Okay, 58.28 degrees. So we found out that angle theta itself is equal to 58.28 degrees. That is the answer to the question, the angle that we are looking for. This angle, angle theta, equals to 58.28 degrees. In the next step, we will summarize the lecture. Actually, we wanted to find out the value of this angle, angle theta. We have here a quarter circle, and inside this quarter circle we have square ABCO. We have also this angle that is equal to 90 degrees, angle AMB is equal to 90 degrees, and we also have this angle, angle BQC, that is also equal to theta, and we want to find out the value of the size of this angle, angle theta. In order to find out the value of angle theta, we made a construction. Actually, we extended 9 segment MA, and we also extended line segment QO until they intersect with each other at point N. Point N is the intersection point of the extended MA and the extended QO. Okay? Then from the quarter circle we created a semicircle, and in this semicircle we have angle NMQ, that is a right angle. It is a peripheral angle that is also a right angle, and we have rule number 1 that states that any peripheral angle that is equal to 90 degrees must rest on the diameter and because of the fact that the peripheral angle NMQ is equal to 90 degrees, it must rest on the diameter. It rests on NQ. That is to say, NQ must be the diameter of the semicircle. So according to rule number 1, NQ is the diameter of the semicircle. But we know that this is a quarter circle, therefore OQ must be the radius of the quarter circle. That is to say, it will be equal to R according to our definition. The diameter NQ is twice as large as the radius. That is to say, NQ will be equal to 2R. So NQ equals to 2R and QO equals to R. And what is the value of NO? NO equals to QN minus QO. NO equals to NQ minus QO. NQ is 2R, QO is R, so NO is 2R minus R is R. So we found out that NO is R and QO is also R. And here we know that the sum of the angles in any triangle is equal to 180 degrees. We have here 90 degrees, we have here angle theta, and we have also here angle M and Q. In total, the sum of those three angles must be equal to 180 degrees. We subtracted theta from this equation. We subtracted 90 degrees, and then we subtracted theta from this equation, and we found out that the missing angle NMQ is equal to 90 degrees minus theta. Then we found out that NQ is the diameter of the semicircle, therefore NQ is a diameter. NQ is a diameter, it must be a straight line. So we can write down that NQ is a straight line. NQ is a straight line. And we have also rule number 2 that the sum of the angles on one side of a straight line is equal to 180 degrees. So NQ is a straight line. So if you focus on the upper side of the straight line NQ at point O, then the sum of the angles here must be equal to 180 degrees. Which angles we have here? We have here 90 degrees, and we also have angle AON. In total, the sum of those two angles must be equal to 180 degrees, according to rule number 2. So 90 degrees plus angle AON must be equal to 180 degrees, according to rule number 2. We subtract the 90 degrees from this equation, and we found out that the missing angle AON is a right angle. Likewise, we focused on the upper side of the straight line NQ at point C. At point C, the sum of the angles must be equal to 180 degrees. Which angles we have here? We have here one angle that is equal to 90 degrees plus angle BCQ. In total, the sum of those two angles must be equal to 180 degrees, according to rule number 2. So 90 degrees plus the size of angle BCQ, in total they must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we found out that this angle, the missing angle BCQ, is equal to 90 degrees. Okay. Then we continue to focus on the right triangle, triangle BCQ. We know that the sum of the angles in this triangle must be equal to 180 degrees. So which angles we have in the right triangle, triangle BCQ? We have one angle that is equal to 90 degrees, one angle that is equal to theta, and the third angle that is equal to angle CBQ. We subtracted 90 degrees from this equation, then we subtracted theta, and we got that the missing angle CBQ is equal to 90 degrees minus theta. Likewise, in the right triangle, triangle AON, the sum of the angles must be equal to 180 degrees. So which angles we have here? We have 90 degrees, and we have 90 degrees minus theta, and we have also the third angle that is angle NAO. In total, the sum of three angles, the sum of those three angles must be equal to 180 degrees. we have 180 degrees on this side, on this side of the equation, and we have 180 degrees on the other side of the equation. So 180 degrees will get cancelled, and we left only with minus theta plus angle NAO equals to theta. We added theta to this equation, and we found out that angle NAO, this angle equals to theta. Okay, so actually all the angles of triangle ABC are equal to all the angles of triangle NO. Both those two triangles have angle theta. Both those two triangles have angle that is equal to 90 degrees minus theta. And both those two triangles have one angle that is equal to 90 degrees. Therefore, you can write down that the right triangle, triangle ANO, is similar to the right triangle, triangle BCQ according to angle similarity rule. And from the fact that those two triangles are similar to each other, we conclude that CQ over OA equals to BC over NO. CQ equals to QC minus OC. That is to say, CQ equals to R minus A, OC equals to A according to our definition. So we can substitute CQ in equation number 1 by R minus A. We substituted CQ by R minus A, so CQ is R minus A over OA. OA is A. BC is also A, and NO is R. So in conclusion, we found out that according to equation number 1, R minus A over A equals to A over R. R minus A over A is R minus A minus 1, that is equal to A over R. In the right triangle, triangle AON, tangle theta equals to R over A, so we can substitute R over A by tangle theta in equation number 1. We did it, and we got that tangle theta minus 1 equals to 1, and A over R is 1 over R over A. So now we can substitute R over A by tangle theta, and we did it, and we got that according to equation number 1, tangents theta square minus tangents theta minus 1 equals to 0. We solved this quadratic equation and we got two answers. The first answer is that tangents theta equals to 1 plus square root of 5 over 2, and the second answer is that tangents theta equals to 1 minus square root of 5 over 2, that is negative number. But from the drawing, you can see that 90 degrees minus theta, it is one angle out of three angles of the right triangle, triangle NMQ. Therefore, it is absolutely a positive number. So 90 degrees minus theta is a positive number from one side. And from the other side, theta itself, it is also a positive number. It is one out of three angles in the right triangle, triangle NQ. Therefore, it is a negative. It is a positive number. So we found out that from one side, theta is greater than 0, but from the other side, theta is less than 90 degrees. In this range of angles, tangent theta is a positive number. But according to our solution, tangent theta is a negative number. So we have a contradiction. So this solution is incorrect solution. We cancel this solution and we left only with the solution that tangent theta equals to 1 plus square root of 5 over 2. We operated the inverse function of tangents on the result, and we found out that angle theta itself equals to 58.28 degrees. Again, we found out the answer to the question that the missing angle theta, is equal to 58.28 degrees. Okay? Thank you very much.